So, so the Tinkercad website should look like this. And you can sign in or sign up. And you can sign in with Facebook if you just...
I try not to sign with anything on Facebook. It just links up way too much information with the world.
Oh, does it? Okay. So I'm just going to start with the rhinoceros. Now, rhinoceros is modeled very closely on AutoCAD and Autodesk. So learning this, if you learn rhinoceros, you can learn AutoCAD or SolidWorks or anything else, any other 3D program made with Autodesk, which is compliant with like the majority of most design and CAD software that we're doing right now. So because we're Canadian, we are going to be designing this in, let's say, small objects, centimeters. So, because it's going to be small. You get this in the opening page. You got to choose your workspace.
Who's got rhinoceros open? So this is the rhinoceros as opposed to...
Yeah.
We're going to do Tinkercad after.
Yeah, we're going to start with rhinoceros.
There's a similar interface.
Yeah, it should be new model and... Okay. So, yeah. Oh, you have rhinoceros. Oh, you have it on this computer. Oh, okay. Oh, the other one? This one? Rhinoceros is a program that you can download, but you can't download it onto these computers. So this is only, this demo will be recorded, so you guys can look it over again. But I recommend that you go, you download this program onto your own laptops.
So even though you don't have, some of you are working in the Tinkercad, they're very similar ideas in rhinoceros, so it's good to kind of watch what's going on here, because all the 3D design programs follow similar principles and use pretty much the same terminology.
Yeah. So basically, when you open Rhinoceros, you're going to get these 4 windows. You get a top view, a front view, a right view, and a perspective view. This is really important, especially in Rhinoceros, in how you interact with the object and how you model the object, because you can do different things in each plane depending on what it is. But we're going to set up our workspace first with the layers. Layers are very important when you're doing any type of design, like Photoshop or anything, because as you know, if you're doing something complicated and you have different parts of a model or an image, you want to be able to work on one part without interfering with the other part. So what I do is I make a construction layer to begin with, and I give it a dashed line. So I'm going to start in the front perspective because that's the most logical. When we draw, we always draw thinking from the front first. And then there's these two little windows. See, there's like this little 4 window, then there's this 1 window right next to it on the top left corner. So I can just go to the front view. I just pop that. Now the great thing about Rhino and other AutoCAD-based programs is you can type coordinates in, which I use a lot. So this workspace, it's about baseball size, which is about 10 centimeters by 10 centimeters. So I'm going to start with the line tool, which is right here, or you can just type L, or line, and then I'm going to start at 0, 0. And once again, starting at 0, 0 as the origin is a good way to work, because when you're importing these objects into like the 3D printer, you're not going to have your object somewhere way off in space where you can't find it when you're importing it. So it's very important to like be as close to the origin point as possible. So I am going to make a line. Oh, I'm going to go to construction because I'm starting with construction there. Make a line at 0, 0. And then you see I got a little line here, and I am in ortho. Right here, this is orthographic. If you choose this, if you highlight it, that means you can only work basically at 90-degree angles. And it's pretty useful when you're first starting out and you're making your construction lines. So 0, 0, and then I want this 10 centimeters high. And I'm working in centimeters. That's what kind of, when you choose like your workspace is centimeters, every unit you're working with is in centimeters. So 10 centimeters high. And see, it's got a line. I haven't clicked it yet, but I can go any direction from 90 degrees. So I'm going to go straight up. And then now I have this line. Now, if you look down here, this says X and Z. Those are the coordinate axes that we are working in. Basically, I can only work, even though this is a 3D object, from the front, I can only go up and horizontally. So vertically and horizontally is the only directions I can work. So if I make a line, and I start at 0, 0 again, and I type 10-0, you always go with X first. The order of coordinates is X, Y, Z. So the first number I put in will always be the X coordinate, and the second will be the Z coordinate. So if I put 10, 0, I get a line that's 10 vertically towards the X direction.
Does everyone understand the X, Y, and Z coordinate? What that means? But basically, what the way 3D space is defined, like so if you're looking at a cube, like anything that goes up is Z, and then X, Y is flat. So X goes kind of horizontally this way, and then Y goes back into space. So that's how when you're making a 3D object, you need those points in all those directions for it to actually be 3D.
Mm-hmm. It'll get clearer and clearer as we like work with this object. So once again, I want to make a line. When you input a number into the program, it's always the absolute. So if I want to make a line from here, and I want the starting position at this point, we know that this is 10x, right? 10 in the x direction. So if I go 10, 0 to start my first line, it starts here. And then if I want to make my next line, say up here, I would have to go, what number do you think I should put in?
0, 10.
Yeah.
10, 10.
Yeah, 10, 10. Because we're going 10 right, and then we're going to go 10 up. So 10, 10. Now, that gets complicated when you're making like a really complex object. So you don't always want to think about the line from the origin point. So there's a way that you can get around that. I hit Control Z. Everybody knows what Control Z does, just to get rid of that line, or you can delete it. So I'm going to start another line, but instead of putting 10, 10 in, I'm going to start with the at position, the at symbol. Now the at symbol basically means you are going to go at the last point that you just clicked. So now the coordinate is going to be from that point that I just started on. So now if I want to go all the way up here, what should I put in with the at symbol?
10.
Yeah, it should be 0, 10. So 0 in the x coordinate, 10 up. And there we go. So that's basically our boundary. So I'm going to go back in here, and you see at the front we have this box, right? And then when we look from the top, we just have basically a straight line because we haven't done anything from there. And then at the perspective or orthographic view, you kind of get your 3D object. So now we are going to make a cup, because that is probably, well, it uses a little bit of everything that we're going to use. So I'm going to start by making the basic profile of a cup. And that requires a circle. So we have our circle right here. And then you can choose different ways to make your circle. You can use 3 points, 2 points. 2 points, basically, you'll start here at the midpoint of one line, and then you go here, then you have a circle. And one thing I forgot to mention is the snaps. You see here in the bottom left, these are called snaps. Basically, if you want your lines to touch each other, you don't want any gaps. And the way that Rhino works with that is these things called snaps. So you can choose for your cursor to magnetically be drawn towards the end of a line, the midpoint of a line, the center of a circle, or the intersection of two lines or a circle and a line. So when I made that circle, it snapped from the midpoint, it says right there, of this line. Oh, that was the center. The 2 point. I hit 2 points, so the midpoint from that line to the midpoint of that line. So now I have a circle. So I am going to make a little center line, because basically I'm going to work this like a pottery wheel. So I just pretty much just need one side of the profile of this cup to make the cup. So I don't really need this, I don't need one half. So I'm going to use the trim command, TRIM, and I'm going to choose this line as my trimming line. So anything that intersects this line will get cut. And I want to cut this part of the circle. So I click that, oh, I hit enter, then I click it, and then that circle disappears. It's been trimmed based on this center line here. Now, the basic form of a cup, I also need to trim the top here, this right here. So I'm going to trim again here, hit enter, and then I'm going to choose what I'm going to trim off, which is that. And I'm going to delete that. And now basically you see here, this is kind of the form of a cup. And then I'm going to go down here, and I'm terrible with ceramic names. What do you call like the bottom of the cup, the part that keeps it from like flipping over? I am not a ceramist, so well, you'll see. Basically, the little standy area. I'm going to use a command called offset. So you see this vertical line that I have in the center. I want to offset it, not all the way to the end, about halfway. So I'm going to offset it by 2.5 centimeters. And then I'm going to click, and then you have it offset 2.5 centimeters. And I clicked the direction that I wanted to offset. So this line here was offset to this line. And I am going to make another offset of 0.5 centimeter. that's pretty good for one of these little bottom bases. And then I am going to trim from this curved line. There. And then I'm going to make this little stand here. Then I'm going to make another line at this point, at this end point. And then, you see, the intersection snap popped between this line that I just created to that line. Oh. And then I want to take this bottom off. Trim. So now we basically have an outer shell of a cup right there. Now, if you're making a one-part mold, all you would really need is that outer shell. But we're going to make like the whole cup, meaning the inside as well, in case you want to make like a two-part mold. So a cup needs a wall. And we're going to make this wall about 1/2 inch. So we're going to use the offset command again. We're going to keep the same distance of 1/2 centimeter. And then I'm going to start just clicking lines. So I'm going to click this curve. And then I want it to go inward, so I click on the inside of this curve. Oh. Yeah. 5, click. There it is. And also, if you use the command, you don't have to type in the command every time. You can just hit enter, and then the last command that you used will be used again. So I'm just going to offset a whole bunch. So now I have the basic shape. I'm going to get trimming again. I'm going to trim that down. And I'm going to trim this. And I'm going to trim that off. And then I'm going to trim between here. There we go. Now, you can choose more than one trimming line before you execute the trim command. So here I chose these two lines so that I can trim in between them. So I highlighted these two, they're yellow, and then I can trim between there and there. So now I have the basic shape of a cup. So I'm going to get rid of all these other lines. Well, some of them. I still need the center line. We'll get to that in a bit. Trim this off. There we go. Now the next thing I'll show you is the fillet command, which we use to kind of like smooth everything off, because when you make basically any object, you don't want like these sharp edges, especially when you're making a mold. So I'm going to type fillet, and then I'm going to I need to make this less than 1/2 centimeter. I'm going to make it about 0.2 of a centimeter, this fillet. And then I'm just going to round the corners. You see, I click two sides. And then it just starts rounding things off. So I'm going to go down here. I'm going to hit enter because the fillet's still there. I'm going to round that off. Enter. And round that off. There we go. Now we have basically the half profile of a cup. So now this is where things we start making 3D objects now. I'm going to use something called the revolve command. Basically what that does is it's going to spin this shape from like a center point until we have like a full 3D object. So I'm going to click revolve. You select the curves. Now the selection tool, you can make like a little window right here, and if you make the window going from left to right, you can only select what's within that window. But if you choose a window going from right to left, even though this line, these two lines here and here, are not within the window, because I'm going from right to left, it will choose any line that intersects with it. So I'm choosing these shapes to be my cup. So I'm going to revolve all this around in a circle. So I choose these. These are the curves that I'm going to revolve. And then it says start of revolve axis. That's what I kept this line here, because I want to make this my revolve axis. I want everything to revolve around this line. And then you just choose which direction it's going to revolve. It's pretty much 90 degrees one way or the other. So I choose that. Now keep an eye on the perspective. Start angle 0, which is what we always want to do. And then to make it revolve all the way around, we make it 360. But if I wanted to make only half a cup, I would revolve it like 180. So revolve angle 360. And there we go. We have a cup. Now this is the line. I'm going to show you what this looks like rendered. And there we go. We have a cup. Yeah. So now remember what I was telling you about like layers? I'm going to make this my cup layer. So I made this layer cup, so I'm going to choose these things, and I'm going to make it cup. An easier way to do this would be to turn off the construction lines, because I don't want the construction lines anymore. They are not useful. So I turn them off, I select all this, and I make it, yep, cup. So now, the construction lines, if I want to export this, I'm not going to export those construction lines, because you don't want to do that, or else you're going to get all kinds of garbage in your 3D print. So now let's take this one step further. So now we can make like an object. Except, you see these are in like multiple, this is in two different sections, right? So if you were going to make a 3D print of this, there would be problems. Mm-hmm. Yeah. So we are going to make this into one object. And we do this through Boolean commands. It's right here. Oh, it doesn't say Boolean, but basically, yeah, here it is. Boolean, two objects, Boolean. We're going to like use union. That's probably the easiest way to connect two objects. Oh, actually, except union only works when things are intersecting. So I got to use Boolean difference, because they don't actually quite touch. Now, Boolean difference is basically you can take two objects and it'll work its damnedest to connect those two together. So you do want the thing to look like what it looks like, but you could get like interesting results otherwise. So I'm gonna hit difference, and I already selected the surfaces, so I hit that, and then now difference. Select surface to subtract with. There we go. Enter. There we are. Now it's one piece. So just to show you again, because two pieces, surface, or solid, difference, you select one piece, hit enter, you hit the second piece, hit enter, and now it's one piece. Yeah. And there's all kinds of other, there's intersection, which basically is kind of what it is. It'll like take the intersection of two objects, and then that's what you'll get. It'll delete everything except what intersects. So that's something. And union, if you have something intersecting, you can only use union of something, but if it's intersecting, it'll make one thing out of those two objects, and it'll just look like, if you have like two beams crossing each other, it'll make an X. But if you use intersection, you have two beams, and it'll only pick that one little cube where the two areas intersect. But I recommend you guys just play around with it, because there's all kinds of different ways that these commands work, more so than just like my cut and dry explanations. So now we got a cup, and let's make a handle. So I'm going to turn off this cup, because I don't need it anymore. Well, I do need it, but I'm going to make a little handle. I'm going to go back to my construction. I'm going to turn off the cup. Oh, I missed a piece. Make that cup. See, I messed up already. So I'm going to do the same thing. I'm just going to do the Boolean difference. Oh. Solid difference. Select. Select. Now I got, oh. What's going on? Things don't always work out. Oh. So I had to, because of just the way it was with that little inside bit, I had to use Boolean to objects, which is another thing you can do, which is kind of similar. Probably because there was a little bit of intersection in that one piece. So it really depends on how the objects are interacting with each other, what commands you can use. So sometimes you got to try a few. So I'm going to turn off this cup again, go back to my construction. Ugh, there's more pieces. Look at all this. Oh, we'll get to that later. Yeah. No, because they were intersecting, it didn't do the difference. Because they're touching it. Yeah, sometimes it's like really tricky, so you gotta really like try a few. Like, yeah, 3D modeling is really glitchy, even though it's been around for 20 years, but it's still kind of new. So really there's a lot of like trial and error.
So, but there will always be a way to know if your object's not working the way that you want it to before you print it.
Oh, yeah. Well, basically, when you select, like, Rhino's very good in that it'll just make it happen. But you want one thing. So when you select an object, you want to select the whole thing, and you can move it around, and if you're losing any pieces, it just won't be connected.
Okay.
So that's the best way to find out in Rhino.
So if you like try to rotate it, you'll just see one of the pieces.
Yeah, it'll just be like left behind. So now I am going to make a handle. And I'm going to make this really quick, just because I want to show you some other commands. Now I'm going to offset this by 1 centimeter. Now this won't be like a real handle because you probably can't get your hand in between this little gap, but that's all right. I'm going to use the extend command because we're working with a 3D object and we have a cup, but the cup is circling in. So even though I have this line and it looks like it's touching the end, in 3D space, it won't connect with everything. So I want this line here to go kind of into the cup. So I'm going to use the extend command to choose this line, and then it'll extend and stop there. Except I need to extend this bottom bit because it's going to the bottom of the cup. Extend. There we go. So we have all our lines kind of inside the cup, which is good. And then I'm going to fill it again. Nope. Fill it, and I'll make this 0.5 because we're going to get a little bigger. So we're going to fill it all this. Fill it. And then that doesn't look right. I'm just going to trim it. Oh, oops. Oh, why is it doing that? There we go. Mm-hmm.
So feel free to experiment and play as you're doing that.
Okay, so right now we have this thing. Now we don't really need these construction lines anymore, so I'm going to just get rid of them because we're just working with a handle now. So I'm going to close this off because we are going to make a plane out of this. Basically, we're going to fill in all this stuff inside here. So we go to Surface. And I hit Surface, wait, just to go over, Surface, and we're going to make a surface out of the planar curves, which basically means the two-dimensional lines that we just made. So I'm going to choose all these lines that I made, make sure that they close and they connect, and then I'm going to hit Enter. And now, you see here, we have like a surface. Now, it's still 2D. We want to make this 3D. So I'm going to make this, I'm going to choose this from here. You can choose from any window, but say I'm working here in the front window, which means I can only go, up into the right? I can only go here and here. But I want this to extend. I want to like extrude, that's the command we're going to use, this going into basically this direction. So I have to use either the top panel or I have to use the right panel to do this, because I can't do this in the front panel because it doesn't go that way. So I'm going to choose the top panel. I'm going to go here, so the top is blue. And I'm going to do a straight extrude. So I can select here. Oh. Actually, no, that's wait. I usually type it. All right. Oh. Extrude surface. Sorry. That's the one. Extrude surface from there. Enter. And then now I can go any direction. And you see how it's going 3D now? So I'm going to do it 1 centimeter. So I'm going to go this direction. I'm going to hit 1, right? And it's going this way from the top view, so we can only go this way. You can see in perspective. And I'm going to hit Enter. So now we have basically the handle, which is a 3D object. So I'm going to go into this perspective view, and then I'm just going to like See, we got basically a cup handle.
I love perspective too. I spent hours.
Yeah. You can just spin around. So, but basically, I'm going to turn on the cup quickly. You see, it's not in the center, right? The cup's kind of like, or the handle is a little off kilter. So I'm going to have to move this. So we're going to use the move command. I'm going to type move, and then we made it go 1 centimeter out. So to make it center, like how far are we going to have to push this? Yeah. So I'm going to type 0.5 going this direction, which is the y direction down, negative y. Oh. 0.5, enter. There we go. And now when we turn on a cup, see, nice in the center. So we're gonna go to the handle, turn off our construction line. Oh, this is still in.
So in both of these examples, basically in the one, it's taking a two-dimensional drawing and then using that rotate to get that 3D form. The second, it's taking a two-dimensional drawing and using the extrude.
Yeah, to kind of like pull it out. Like, was anybody here? Oh no, I guess not, maybe. But there's like this chair that somebody made out of cardboard. And it's pretty flat. And it's like the shape of a chair. And it's about that thick. But you can pull it out like an accordion. It was actually here, like somebody designed it here. Yeah, you pull it out and then it's like a couch. So that's kind of what we're doing.
That's the extrude.
Yeah. So I'm going to turn off these construction lines again. So now I only have the handle, which I just made into the handle layer, and I got the cup. Now because these are, if you look in here, they are intersecting, I can use the union command. So I can go select one surface, enter. Oh, I got to select both. Wait, hold on. Union, select these two, hit enter, and now it's one piece. So
basically, if you wanted to make a complex form, you could, for instance, take a sphere in one layer, take a sphere in another layer, take another sphere in another layer, put them together, and then use a union, and then it makes one big form. So separating out the layers makes it easier to work with more simple shapes in each layer, and then using the union command kind of put them together.
So planning is very important when you're using these. You have to think, how many layers am I going to use? How many like unique objects? How are they going to interact? How am I going to make these into 3D forms? So basically, you know that wire thing that we did like at the beginning, like the second week of class? You're going to think a lot about like how you thought about different ways of making a wire, because I think everybody, there's like 3 or 4 different like strategies to making like a ball. And that's the same thing here. There's a sphere command, but you can also basically do what I made with the cup. You make a half circle and you can circle it around and you got a whole circle. So it really depends on how your mind works.
And so part of when you break into groups, one thing that would be really useful is in your group, make sure there's someone in that group who is computer comfortable. Figure that out, and then work together for that too, so that you're not, all kind of sitting there and trying to figure things out. So Chris, what about an hour?
Okay, so basically, I'm just going to get rid of these just because I forgot to unionize them, but it's all right. So now we have this one object. See? It's one thing. We are going to export it. This is how we make it so that it will be 3D printable. So export. Now I'm just going to put it in the desktop. And we want to export it as a stereolithograph file, or an STL file. This is the only file format you can use to make a 3D print. So you have to make sure, so the 5 people who will be responsible for this format, you have to make sure that the format that you give Phil is an STL file format. So, and I'm just going to call this cup too, because I already made a cup before. So you just export it as a cup, and then we do like this tolerance here. What we do with an STL file is it basically takes this form that we did and makes it into like a whole bunch of like little triangle planes. So I can preview it right here, and this is what it's going to look like. This is what the 3D printer sees when it prints it. So all these little triangles and all these little shapes, it's going to make all those things. So I'm just going to hit OK, because that's fine by me.
And so the way the 3D printer works is each of those shapes, those points, is where the inkjet head is going to draw.
Mm-hmm.
So that's why you need all those points. So the cup version, that looks beautiful, but you can see it's only got like 8 or 9 points. So a printer would understand that with a really angular shape. So it has to translate a curve and use those points or the printer understands that.
And now I'm going to show you something else, because there is an option. Like if you just say, you know, I like the 3D printing, but 3D modeling isn't my thing, you can import existing shapes. So this is a piece that Deanne did a few months ago. This is it's a rhino, which I think is funny because it's a rhino and rhino. And hopefully, okay, there it is. So I'm just going to move this so that's not in the way of the cup. Now you see how tiny this thing is. Look at this. So really, like, this is as big as you can go, baseball size, but you don't have to necessarily make something. These are little plastic stamps that Deanne and Brendan Tang, who also is a professor here, they collaborated on their own project to take a 3D object and transform it.
And the way I made that was just extrusion. I did
Yeah.
a drawing, and then I extruded it.
Yeah. As you can see, yeah. See, here's the rhino head. It was just a shape. You can import vector files from Illustrator into Rhino. So you can take a 2D like drawing, as long as it's a vector file, and then you can extrude it, which is basically what Deanne and Brendan did. And basically what we did with like the cup handle, they picked all the sides to a closed shape, they made it a plane. So they did that a lot. They made a lot of little planes.
Yeah, so I did, in the case of this project, I did a drawing in Illustrator because that's what I'm most comfortable in. I don't do Rhino that well. I imported it to Rhino. I extruded it 1 millimeter up because we're doing these very small objects. And extruded the base 1 millimeter down, and that's why you've got these 2 levels. Made everything into a plane using that surface plane button that we showed. And then I joined it using Boolean difference, and I think that was it.
Yeah. So it could be as simple as that.
Freya has a question.
Oh, yeah. Excuse me? To make the rhino?
For a beginner? Yeah. It depends. So, I mean, for me, most of my drawing is in Illustrator. So I spent most of my time in Illustrator, but the Rhino part is literally 10 minutes. So it's actually expensive to enjoy the first one.
Yeah.
If you're doing something flat.
Yeah.
Like that, right? But that's a pretty flat 3D object. That's not really.
Yeah, we'll do a little brainstorming after this tutorial when you guys get into your groups, and then we're gonna like kind of like talk about what you're most comfortable with. But in general, this took an hour, but that's because I was explaining throughout the whole time. In general, it takes me like 15 minutes to make a cut. So if you like put 3 hours, that's being super generous. Like 3 hours, you can get something done.
And remember that with this project, you don't necessarily have to make, unlike your last project, it's not about a recognizable object.
Yeah.
But it's an object that everyone in the group is happy with. And more importantly, that you can make a cast out of it. So
Mhm.
anything that you learned about, say, undercuts or those types of things is a good thing to kind of think about. So that if you make an object that's really complicated, again, you're gonna have a hard time casting it for different numbers.
Mm-hmm. So I'm going to jump to Tinkercad, which all of you can follow now because this is on the web.
Yeah. So yeah.
All three of us have tried signing up, and it says server error.
Oh no!
I did that the first time, and then I tried again the second time, and it worked. Yeah. So
Yeah.
for those of you guys on the computers now want to open Tinkercad, and for those of you on Rhino, I'm going to walk around and help you out.
Yeah. So I haven't used Tinkercad a whole bunch, but I'm going to show you something cool about Tinkercad. Is that you can import files into Tinkercad as well. So I'm just going to import Deanne's, or actually I can import the cup. Desktop. Cup. So here is the cup that I just made in Rhino. It's now in Tinkercad. So it's a very good program if you just don't want to, really learn like a 3D program, and you just want to like put something in. So this is the cup we just made, basically. So here's all the little vectors. It looks a little rough, but that's all right. The 3D printer is kind of rough in general. And basically, the way that this Tinkercad works is it's designed primarily for 3D printing. So whatever you export out of this, it'll try to jam it into one object, no matter what. So you don't really have to worry so much about union in Tinkercad. It'll just make it. It'll just like work its damn. Yeah, whatever you put together, it's going to try to make it into one form. So like, if I throw this like little, it's a little touchy, the cylinder in, there's these little, I guess, snaps. It has its own snaps too, see? Where you can change the way this thing works. There we go. And then there's this little, the way you move around is this way, so it's not quite as accurate as Rhino, but it's close. So let's say I want to make a cup that is impossible to drink out of. You can download it for 3D printing, and then you can make it an STL, because that's the important bit. And it names things its own name, I don't know why. So now, I'm going to go back to Rhino and just kind of show you what it will look like. Here it is. Now, that's one thing, is I guess Tinkercad was set in millimeters, so the units are all off. I know. So 10 centimeters is now 10 millimeters. But you see, this now is one object. It just forced it. It just jammed them together.
So for those of you who are less comfortable, if Rhino seems really complicated, Tinkercad may be a better kind of beginning entry point because there's a lot of places that you can start that are already pre-made, like shapes on the side, and then just kind of jam them together to make a new shape. The first time, for instance, that I made a 3D model, I made a figurine of a person, and I started that with just 2 cubes, and I just kept extruding it. So I took 2 cubes and I split it in half, I extruded parts of it to make a leg, then I joined it again, I extruded again to make a body, then I split it and extruded again to make hands. So you can start with something really simple and make it quite complicated over time. It doesn't have to start out looking that complex.
Mm-hmm. Now, this is, right here, this is another website called GrabCAD, where if you just don't want to do anything, you don't want anything to do with modeling or making anything in any way, there are models that you can download. But I recommend that you try to at least model something. I say GrabCAD is your plan B if your model just isn't working between like the 3 or 4 of you. But I have faith that you guys can do it. But basically, yeah, great. Yes, it's all on the Moodle. If you go to Moodle, all these links are on the Moodle. So, so basically, where's the search? Here it is. I'm gonna look for a cup because that seems to be like. So you can go and you can find a cup, and then you can download the cup. And then I can go to, so now, basically we're going to take some time and you guys choose one of the programs, whichever program you want, and just play around with it a bit. We're just going to take some time to play around the programs.
And we'll walk around and kind of help.
Yeah.
Just start to make something, that somewhat. Do you want to show figures as well?
Oh yeah, well that's another thing like GrabCAD. Yeah. There are many free 3D programs. This is another one called Thingiverse, and they also have other 3D objects. But Thingiverse is objects made specifically for 3D printing. So all these things have been 3D printed.